My warmest welcome to everyone. I'm so pleased to have you join me back in my workroom at 24 Washington Avenue for the second part in my 1890s patented wire mesh bustle recreation exploration. First things first, enormous heartfelt thanks for the subscriptions that have pushed this channel over the 1,000 mark. I didn't have any major expectations when I started sharing content just over a year ago, but your support means everything. If you haven't yet watched part 1, I highly recommend that you do, as not only do I share the step-by-step for making what proved to be a very surprising supporting form, but I provide a very important overview for the two patents that I'll be working on in this video. Do be sure to watch to the end, as I will show you all three bustles in a side-by-side comparison, and I would love to hear which bustle gives the look that you prefer. Spoiler alert! They each give a very different silhouette. And don't forget that I very much value your support through comments, likes, and subscriptions. The second bustle in this series was patented by the creator of the first, Henry H. Taylor. I'm going to suggest that it was mainly an attempt to reduce the quantity of wire mesh used while maintaining the same overall effect. As such, because nothing is doubled over like it was in the first, I can apply my 8 inches tall and 10 inches wide measurements taken in the first video and make a rectangle that size on my drafting paper. I'm actually having second thoughts about the dimensions of this bustle template. Looking at the images, it appears quite wide at the bottom. Now, these bias cut edges will be compressed, so all of that extra width at the base is going to transform into fullness, and when finished, won't be so wide. So I am adding triangles at the side to accommodate this shape so that when they compress, I'll still be right around that 10-inch wide mark I'm looking for. I position this paper template onto my mesh, chalk, and cut it out. The design and description show that the mesh can be cut with or without the bottommost corners. So let's take a moment to look at that. When the edge is compressed, you can see how it forms the curved base as we see in the patent, but there is also a slight curve to the sides. If this bottom protrusion were cut off, the edge would extend downwards straighter for longer. Holding my finger in place here while I release the edge, you can see that the resulting line would be the same as shown in the first image on the patent. For this bustle, I also need to make two panels for the underside. Their height will match the height of the sides of the compressed mesh, so I need to work that out first. I've compressed this edge and it measures in at about 5.5 inches. The binding tape runs all the way around the outside, so I'm proceeding to pin that in place. For the lacing panels, I cut two 7-inch wide rectangles out of fabric, which I folded in half, right sides facing in, sewed the top and bottom, and then flipped it right side out. A difference I'm already seeing is that the patent shows the sides fairly straight with a curve at the bottom, whereas mine appears to be curved all the way around. If I flex the sides to try to conform more to what's shown in the patent, you can see how much it affects the overall shape of the bustle. So off camera, I'm going to play around with it a little bit here and there to try to get closer to what I'm seeing in the original design. It does seem that the edges should align with the straight edges of my panels, but if, after making adjustments, they still don't match perfectly, then I'll probably just have to curve the edge of my panels to match. I've made adjustments and have the panels pinned in place. Yes, there's still a slight curve there. I've placed some short lengths of zip ties into the inner edges of the panels to stabilize them once the eyelets are laced. Not so different to how you'd stabilize the back of a corset. Now to the sewing machine. This, as shown in the first video, is my Singer 3115 heavy-duty tailor's model. With the edges bound, I'm going straight to adding the waist tie, which doubles as binding for the top. It's time to set the eyelets into the lacing panels. The patent shows what appear to be metal eyelets, so that's what I'm going to use. But I'm going to take advantage of work that I can do in my lap and pop downstairs to be with my family while I set the eyelets. To make up for the lack of footage covered making the waist tie for the first bustle, here's making the lacing ties for the second. I'm running bias tape through a binding attachment which folds the tape in half and then stitches the edge in place, a very useful tool. Now lacing the panels. It is immediately apparent that the center of this bustle is unfortunately sagging under the weight of my skirt. I tried pinning some boning in place at the bottom edge to provide more support, but it didn't seem to do anything. As soon as there's any weight in the center, it collapses. And even with the lacing tightened, this is still collapsing under pressure. One thing that's come to mind is that the patent shows the bustle rather squared at the sides, whereas mine is very curved. So I'm wondering if maybe I need to modify my creation to incorporate some corners to help stabilize it. I clipped the edges at the points I decided would make good corners, took the opportunity to insert a zip tie across the base, and now I'm trying to force the sides to be straighter. The mesh is great to work with in this case because you can force a shape on it that it's quite happy to keep. I'm then trying to shape the rest of the mesh to take the target dimensions. It feels like it's a lot more solid, so let's throw the skirt over and have a look. I'm actually quite shocked by what an improvement that's made. But let's have a look at the third design before we do a full comparison of all three. I've been really excited to make this third bustle. Submitted for patent status in 1898, this bustle always looked like it would be the most supportive of all three. I'm going to use my 8x10 rectangle as I did with Bustle 2, and then transpose the round outline as showed in the patent images. Looking at those images, you can see how the mesh is cut at a different size to the backing fabric. And when you look at the mid-construction image, you can see that the mesh is both longer and wider than the backing piece. So I'm going to add a second template for the larger mesh, which gets compressed down to the perimeter of the backing. The mesh will be the same dimension at the top, but then flare out at the sides and the base. The paper template has been cut out, chalked on the mesh, and the mesh is cut out. The backing now, I'm simply pinning the paper template to some lightweight canvas. There's no need for any seam allowance because the whole thing will be encased in the binding. The patent images provide a useful construction order reference. First, the top edge is sewn, and then stitched all around the outside, presumably compressing as you go. So we'll go straight to the sewing machine. Top first. Because the mesh is going to want to push off to the side of the canvas as I stitch, it's important to align the center base. This will also ensure that I gather the fullness at the edges more equally. Maybe pinning this beforehand would have been beneficial instead of forming as I sew, but being so close to the curved edges meant that the wires wanted to separate, so I'm thinking that this order was necessary for the integrity of the mesh. Quite an impressive shape! And here's a sneak preview of what it will look like in place. Yes, I'm definitely excited about this reconstruction. There is clearly more concentrated fullness at the base of the right than the left. The explanation for that is that on the left I was sewing from bottom to top rather than from top to bottom. But I'm fairly sure I can manipulate the mesh to better distribute fullness, so no major concern. Besides, humans aren't perfectly symmetrical, are they? It happens. I ran out of the bias tape that I had used for edging in the first and second bustles, so need to make some more. Here I am using a travel iron from the 60s or 70s. I actually bought it for the cord as the Bakelite handle on my heavy 1930s iron got bumped last year and shattered. But despite looking quite shabby in the photos, this iron cleaned up like new, so I'm putting it into use. It heats up very quickly and, due to the iron plate inside, retains its heat for a good amount of time. You are only supposed to leave it plugged in for 5 minutes at a time, as it does not have an automatic shut-off and will keep getting hotter and hotter. Back to the sewing machine, where the new tape fits the form perfectly. You can see that I haven't taken the step to pin it in place, I'm just sewing and forming as I go. With the edges secured, I can attach the waist tape and be done. Ready for the reveals? Be prepared to pause if you want to look at the images for longer. First, here's a reminder of Henry Taylor's first bustle. And with a skirt. Now here's Mr. Taylor's second bustle. And skirted. And finally, Mr. Harry Keil's design with a skirt. For our side-by-side bustle lineup, here they are. And a side-by-side of the resulting silhouettes. I find it remarkable how the weight of the skirt ends up redistributing the fullness in the wire mesh for each bustle. And given that these were patented barely 1 year apart, the look of each one is really quite different, don't you think? Thanks again for spending time with me today. I truly hope that you enjoyed this presentation and would appreciate your feedback through a comment, like, and channel subscription. I'd love to know which bustle you preferred. Please let me know in the comments down below. I'm going to sign off now, but look forward to seeing you again very soon when I return with another historical clothing process or vintage machine exploration. Bye now.